Right, today is the last day that we're going to be studying circles for a while, a couple weeks at least, I'd say. And when we get back to circles, it'll just be for review at the end of the quarter. All right, so yesterday we reviewed the first week of circles, which was finding the measure of an angle depending on where the vertex was compared to the circle. Now, today it's going to be week two of circles, which was finding the sector area, which is part of the area of the circle, not the whole circle, just part of it, and finding the arc length as opposed to the arc measure. So basically, we're finding the circumference of the circle, and we just want to know a part of that circumference. So that'll be example two. Here's example one, and this has to do with sector area, which is area of a shaded region of a circle, part of the circle. Well, the area of a circle is pi r squared. So if we did pi r squared for this problem, that would tell us the area of the entire circle, which is what we have to start off with. We got to know the area of the entire circle, and then we divide it by whatever fraction, or we multiply it by whatever fraction of the circle that we're interested in. So let me do this problem for you. We start off with pi r squared, and that'll give us the area of the entire circle. So what is r? What is the radius? Well, the problem doesn't specifically tell us what radius is. It does tell us what the diameter is, and the diameter is always twice as much as the radius. The diameter is all the way across the circle through the center, and the radius is just halfway from the center to the edge of the circle. So if the diameter is 12, the radius is 6. So the area of the whole circle is 36 pi, 6 squared. So we've got, I'm going to leave this in terms of pi, and in the work, I think they want your answers in decimals. So when you get to the end, you're going to have to multiply by 3.14 with your calculator. But for now, the area of the entire circle is 36 pi. But we just want to know that shaded region. And what percent of the circle is that shaded region? It's 60 degrees of the circle out of a total of 360. So you multiply by 60 over 360. Whatever the degree of that central angle is of that shaded region, divided by 360, which reduces to 1/6. So we basically want to know 1/6 of the area of the circle. So 1/6 of 36 pi is 6 pi. There you go. All right, so the area of that circle is 6 pi, and the diameter was given in inches, so technically it's 6 pi inches squared. Remember, when you're dealing with area, it's your units squared. All right, and like I said, if you had to multiply by 3.14, then you would go ahead and do that, and it'd be 19 point something, or no, 18.84, I believe. All right. The other part of this standard from the second week of circles was finding part of the circumference. So pretty similar to what we just did, we're going to use the formula for circumference instead of the formula for area, and then multiply it by the central angle over 360, just like we did with the area. So in this one, pi times diameter is the circumference. Well, we don't know what the diameter is. All we know is what the radius is. It tells us that AC is 20. And in all these problems, C, or whatever that angle is, it's going to be right at the center. So C is the center. All right, so if AC is 20, that is the radius. So if the radius is 20, then the diameter is twice as much as that. The diameter is 40. So the circumference of this entire circle is 40 pi. So if we wanted to know the circumference, which is a fancy way of saying the perimeter of the circle, all the way around the whole thing, it's 40, but we just want to know from here to here, from A to B. So we just want to know part of the circumference. That's called an arc, and an arc gets its own symbol. It's no longer C, now it's S. S stands for arc. And S is pi diameter, because we're doing circumference, but it's part of the circle, not the whole thing. So you multiply it by 72 over 360, because we were given that angle ACB is equal to 72 degrees. And I was nice and I gave you an angle that goes into 360 evenly, in this case 5 times. 5 times 72 is 360, so that can reduce to 1/5. So we have 40 pi times 1/5, And when you multiply by 1/5, it's like dividing by 5. So 40 divided by 5 is 8. So your arc length in this one is 8 pi. And if they don't want the answer in terms of pi, then you have to multiply that by 3.14. And that would be 25 point something. All right, so there's your review from the second week of circles. I believe that would be the week of April 6th. So if you have trouble with this standard, you can go back and review the week of April 6th.